Motion along a straight line, 3.13, displacement, speed, velocity, and acceleration, distinguish between instantaneous velocity and average velocity. Question, which of the following situation will be related to distance and which to displacement? Now, if we look at the picture, we see that speed is going to the right, 2 meters per second, and the same object can be going to the left with the speed of 2 meters per second. Velocity, when going to the right, you could have velocity of 2 meters per second, positive, we see on the diagram. When it's going to the left, it has a velocity of minus 2 meters per second. So from this diagram, we can definitely see that as in our previous analysis, the distance will always, total length of path traveled, this will always be positive, it can never be negative. And displacement is positive or negative depending on which way, which direction is the object moving. That means speed must necessarily be related to distance, and it is a scalar quantity, and velocity, it is related to displacement, and it will be a vector quantity. We see it's very important in velocity the direction of the motion going left, right, up and down, and or going around in any type of angle. The next question is, what if the motion is in one direction only? For example, this lorry is going from left to right, straight line, which is called rectilinear. Recte is coming from Latin, which means straight. So rectilinear motion going from left to right. In this situation, because you're always going in the same direction, never change directions, speed and velocity are the same thing. Because in this situation, distance equals displacement. If the lorry starts here at this point and is stopping at the end of the dashed line, the lorry would have moved, let's say, 10 meters, which is distance in a straight line, and it also means displacement. Look at the following diagram. What do you think is the difference between instantaneous and average? We see here x in meters, that means distance, and then a time. So we see that the object didn't start in the origin. The object started 5 meters away from the origin, which is no problem. We always choose when and how to do our calculations in physics. So the object moved from 5 meters to all the way to 30 meters. So the displacement between the initial and the final position is 25 meters. But we see that the object's path was a little bit, it was not done in a straight line. It took the object from 0 to 10 seconds. It took the object 10 seconds to go from 5 to 30 meters. Here, what is the difference between instantaneous and average? Now, if we need to calculate average, we know that the overall distance is 25 meters, the overall time is 10 seconds, so that means the average should be 2.5 meters per second. Now, if we need to calculate the instantaneous, that means in a specific point. For example, this dot represents an instant in this motion. Obviously, when an object is moving, any kind of object, when it's moving in real life, the object will be moving faster. The object will be moving slower, then it will be moving faster, then it might be stopping sometimes. It has a variety of different motions. For example, if we just need to calculate the motion at a specific instant on our road, on our trip, which is called the instantaneous velocity, or the instantaneous speed, which is what the speedometer gives us. We practically put a dot on the position that we need to analyze, and because like this, in this, it's very, very difficult to do it. We need to use a bit our mathematical skills. So practically, if we have a curved line, which it means it's very difficult to use the calculations to find out what is the slope of this motion. Practically, what we need to do, we need to draw a tangent to the specific point that we need to analyze. So we see we want to see the speed of that specific object at 3 meters from the origin. I'm drawing a tangent, and then I will create my triangle that will allow me to calculate the slope of this specific motion. This triangle can be smaller, can be bigger, but as a rule of thumb, it will be good to take at least half of the graph that shows a big image, and it's very easy to analyze it. So we have the rise, a change in y being the distance from the origin, probably, or we have the x, the change. We have the change, the horizontal, the change in x, which is probably the time. So calculating the slope is equal as rise over run. So the change in y over the change in x, and that will give us gives us the instantaneous velocity at that specific point. So using a tangent. What's the difference between velocity and acceleration? That's going to be on the next slide.